Hello everyone, can you please check whether my voice is audible or not? Perfect, thank you. So before going to begin the master live class on SQL today, so I hope you are ready with the MySQL software in your system. I've already made a video to how to install MySQL and PostgreSQL in your laptop. So do watch the episode number 2. It will take like 5 to 10 minutes. So you can complete the installation and then you can like you can be ready with the SQL. I mean, how to write queries, everything and all. Initially, first 10 minutes, I'll complete my what we call the theory part. What is data, what is database, and what is database management system, everything. Then I'll getting into the actual demonstration of all the SQL queries. I hope my point is clear. Can I get a quick response in the chat? I could see like the people are getting joined. It's a good response. Uh, Manoj, Sai Teja, Bablu. Not like Instagram, like in YouTube, the names will be different. Not their actual names, it will be different. Right? So, uh, prerequisite for this live class is there is no need to have any kind of foundation. It's just completely where you can learn from scratch. That's why while I'm doing the full stack development series, I don't want to develop a project directly. I want to do kind of a basic to advanced level. So that's why I started with installation, and then I covered Java topics because which is very important for Spring Boot projects. Not complete Java, like OOPS concepts, because you need to know what is class, what is interface, how to create what we call classes, objects, everything on the along with the Java 8 features. And then I covered Git also last week, Git Master Class, because when we start our development from next week onwards, like for every video, at the end of the video, I'll push the code into my GitHub. So I'll so my every video will be like a combination of kind of a development plus Git part. That's why I covered in prior. And now database, it is just you can learn from scratch. There is no need to have any kind of prerequisite, but the only prerequisite that you need to have is MySQL or PostgreSQL installation. MySQL, PostgreSQL installation. The software should be there in your system. Make sure. But for today's demo, MySQL is enough because whatever the queries that we are going to do, it will be same in the both MySQL and PostgreSQL. Uh, like so, I'm going to do in MySQL because even in the end of the episode 2, please watch episode 2. Please watch episode 2 for the installation purpose in the YouTube. Right. So it will take like a 10 minutes time up to. You can just complete in very fast, sorry, very fast mode. It's 2:09. Let's start. Let's start with introduction before going to getting into the demo. First, we need to know some terms. Without knowing those terms, we can't proceed with the demo and all. So my first definition will be data. Data is nothing but it's like a raw object or like which are not processed actually. So it will be something like a raw, unorganized facts or some kind of figures, just numbers, I can say, not images or some characters that lack context or meaning, that lack context or meaning on their own. So data is nothing but something like unprocessed facts. So there will be only data, but which are yet to be processed. For example, let me take a data, like for example, uh, Amit is the name of the employee. He's earning like 85,000 salary and date of joining something like I'm taking as a string. If I'm not keeping any data in double quotes, that means it's a number. 2025 01 01 15. So this is something like a format like the year, month, date. So this is just data. Now, what is information? Information is all about processed data. Processed data is called as information. It is a processed and as well as storing also, like a digital collection of structured data designed for what are the information we process. I mean, what are the data we process? We call it as information designed for efficient storage, efficient storage. So I can say, if anyone asks you like what is the relationship between data and the information, don't say both are same, both are different. Because data is a like unprocessed fact, information is nothing but processed data. I can say information is equals to f of t. F of t. This is the relationship between information and like data. For example, if I take f of x is equal to x plus 2, it's just a kind of a equation. If I provide x is equal to 2, so 2 plus 2 is equal to 4. Like the 4 is like the result. That is nothing but information, right? So simply I can say data is nothing but unprocessed, whereas information is nothing but processed data. Give me 1 second. Information is equal. So where I is nothing but where I is information and B is data. The next definition will be database. Database is nothing but an organized digital collection of data. As I mentioned in the data definition also, structured data. There is a schema that is called a structured design for 1 second. Database. Database is nothing but an organized. Give me 1 second. I just want to I just want to change the definition of information like this, because information I can't just directly say like a efficient storage. So let me just change some words in the information. Information is nothing but information is nothing but processed, and here I just want to change as structure, and it is just based on the context also. So contextualized data that becomes meaningful, right? Like unprocessed data. I can simply say processed data is called as information. For example, I've taken example in the data like Amit is employee name, 85,000 salary, and like joining date is January 15, 2025. When it comes to information, Amit earns 85,000 85,000 per year. If I mention designation also as an engineer. So this is nothing but a statement after processing the data. Now, as I said, relationship between data is nothing but I is equal to f of d, where I is equal to information, d is nothing but data. Unprocessed facts is called as data. Processed data is called as what? Information. Now let me just come to database. Database is nothing but an organized digital collection of structured data designed designed for efficient storage. Efficient storage. Efficient storage. Database is nothing but like an organized digital collection of structured data. So we are going to save the data for the efficient storage. Next one is database management system, DBMS. Basically, it's a software. So it is a software S/W shortcut software that acts as interface between between the and database files and its end user, database files and its end user, database files and its end user applications, end user applications, handling not only handling the application, it is going to handle the security also, because the entire data will be saved in the like your data. So we just need to secure our database, and concurrent access, because multiple users are going to access your database. For example, whenever you do any kind of transactions from the front end, when you make an order or making any payment, everything and all, that is going to hit your database, right? So what are the action that you're going to do through front end UI that will be performed on your database? So multiple users are accessing. That is called as concurrent access. Concurrent access. And when your system is collapsed or crashed while doing any transaction, the database should be able to recover the data also. That is called as recovery. So so we are done with the data definition, which is unprocessed facts, information, which is processed data. Next one is database, and then a database management system. Now here the very important RDBMS. RDBMS is nothing but relational DBMS. There is a biggest difference between RDBMS database. Let us all see what is RDBMS is. A specialized DBMS, a specialized DBMS based, a specialized DBMS based on the relational model introduced by EF Cord. EF Cord is one of the persons introduced this RDBMS. EF Cord. Data is stored in tables. So he mentioned that data will be stored in the tables, like structured format, that are linked. that are linked or related to each other based on matching foreign key constraints. So what is constraint, what is foreign key and all, we'll see in detail in the upcoming topics. But one important point is like RDBMS is more of creating tables and the relationship between tables. Foreign key is used to join two tables. Okay, like I mean using one table also we can apply foreign key, but generally there will be two tables and making a relationship between them, that is called as RDBMS. Now next one is table. Table is also called as relation. And I just want to highlight one point that DBMS is more of files, I can say files, and RDBMS simply more of tables, simple logic. Okay. And a table is nothing but a two, because even in database also I didn't mention about the structure and all, but files can be saved like anything with a different structures format, and without structure also like we can store. But RDBMS will follow a specific structure. That structure is called as tables. Table is nothing but a a 2D, two-dimensional grid, I can say, of related data. Related is very important word, because if I say student related data only will be saved. If I take patient related data only will be saved. So related data, data, data entries consisting of consisting of horizontal rows. Rows will be horizontal and columns will be vertical, right? The next one is row, and I want to highlight one point. At any moment of time, you can go backward also, like it's a live, like you can go forward, backward, like anything, if you miss any topic. Row is called as first, next one is row. Some people will call it as row as a record. Some people will call it as tuple or tuple. So row is called as a single implicitly structured data item in a table in a table representing an independent real world entity instance, real world entity instance. So simply, it's just of course there are multiple items in the table. Each item is called as a row. Like it is considered as here entity is nothing but relation, right? Entity is nothing but what, relation or a table. Next one is column. As I said, table is nothing but I'll write here. Table is table is a combination of rows plus columns. It's a 2D grid, two-dimensional grid, 2D, 2 by 2. I mean, 2D is like rows and columns, 2D. Next one is column. Some people will call it as column as attribute, or some people will call it as column as a field also. Field. Now, a specific property or a specific property or data element of a particular type, because every column value contains a type. For example, it is maybe string or number or boolean or anything type shared across shared across shared across every row shared across every row of a table of a table of a table. So table is nothing but rows and columns. Row is nothing but a single, I mean, a single implicitly structured data item, which is a real world entity instance. Column is nothing but a specific value, which may consist of different types. Next one is degree. Degree is nothing but the total number of columns. Columns is also called as attributes. Attributes. Columns are also called as Teja, I just want to highlight one point that I've already mentioned many times in my YouTube channel. This channel is not for contemporary technologies at this moment. My objective is very clear. It is from the beginners. So if you want to learn if you want to learn any kind of contemporary technologies, you can watch any other YouTube resources also. So it's me, like it is from the college students who begin their journey from competitive coding, web application development, followed by specialization subjects or contemporary technologies like DevOps and all. So if you want any kind of contemporary technology like Gen I, ML and all, this is not the right channel at this moment. For sure, this channel will provide you content on contemporary technology soon, but not at this moment. I hope my point is very clear. Yeah. The total number of columns attributes present in a table. The total number of columns present in a table is called as degree, and cardinality is nothing but the total number of rows, like we call it as tuples, or we can say records also present in a table. So this is the introduction terminology related to SQL. The first one is data. Data is nothing but unprocessed facts. Only at the beginning I'm revising, but later you can just go to previous. You can just forward and backward, like in the YouTube live whenever you stuck any moment. And then we discussed about information, and then RDBMS, DBMS, table, rows, columns, degree, cardinality. Now, very important point, SQL. That is what we are going to discuss today is SQL. What is exactly SQL? SQL is nothing but structured query language. So we have a data, we have database, we have RDB, we have database like software, everything and all. Then we need to have communication or interaction with the DBMS software, right? User want to interact with the DBMS. So for that purpose, we need a language. So the standard declarative programming language, the standard declarative programming language used to communicate with, manage, and manipulate relational databases. It allows it allows users to define, we can define schemas, update records, we can update the records, we can alter the tables, we can delete the records, and extract highly specific data views. View is nothing but a part of the table. So I can say, for example, client is there, or user is there, developer is there, whatever, user. He want to communicate with DBMS software to perform CRUD operations. Okay. So he need a language. That language is called as a query language. So based on query, we are going to interact with DBMS to perform CRUD operations. So basically, what is CRUD? What is CRUD? CRUD operations. C is nothing but create. This is nothing but insert operation. R is nothing but retrieve, retrieve. That is nothing but display. Or people will also called as a select also. Like whatever, there are multiple records are there in your table. I want to view few records, like selecting the few records. Next one is U. U is nothing but updating the records, and D is nothing but delete. This is the CRUD. So SQL is not only about only CRUD operation. There are multiple queries, different queries with different operators. But the uh, query, main queries are insert query, like select query, update query, and a delete query. So I can say query is nothing but a question, because even in your chat GPT or Cloud, any kind of AI model, first we need to provide a query or question, right? You're asking, generally in the high level language, like English, like a statement, you will ask display all records in the table. That is a direct question, right? So that question will be converted into, in NLP, like in the AI and all, that question will be converted to, let me just take an example. For example, in AI model, for example, I'm just going to ask a question like this. The question is display all rows or all records, in student table, for example. So this is my direct question, right? But this query, so using NLP, natural language processing and all this kind of a question will be converted to a query. So that query is going to hit the database. So based on the query, the results will be displayed, right? But here the query is not directly a like high level language statement. The first approach will be like we need to use some keywords and all. So for example, select is the query we need to use. Example purpose I'm taking. So I ask all records in the table. All means star and from table name. Table name is for example student. So this is how we have to write. But select star from student is like kind of I mean developers will perform this kind of queries. But as a normal user, as a client, I don't know how to write queries, for example. So what I'll do is like I'll ask as a question, like a prompt. So that prompt will convert into query and using NLP and other technologies. So that query will go to date table and fetch the records if the data is there. So that is how approach will be. So now we are learning how to write queries, but the latest technologies where we no need to write the query also, we can directly integrate with AI so that you can directly ask questions, right? But as a developer, you need to know like how the queries will be generated in background so that then only you can be able to optimize the queries and you can be able to complete the database setup and all. So you can't completely develop on AI because first you need to know the basics, foundations and all, so then only in future, if you want to change or modify anything, you can do that if you know the basics, right? So we discussed about what is SQL, and now let me just talk about SQL sub language. SQL sub language reference. We call it as database languages also, DB languages. Some people will call it as DB languages also. Let me let me just talk about the first one, which is DDL. DDL is nothing but data definition language. Data definition language. Data definition language is nothing but it defines, alters, or destroys the physical the physical structure, the physical structural schema that is a table of database objects. I just want to highlight another point that in DBMS, generally, like as I said, DBMS is a software. Like, I just want to highlight the different types of softwares also. What are the different types of DBMS softwares we have? Database management softwares. We simply call it as different database technologies for reference purpose. So, like the first one is Oracle SQL, Oracle SQL. Next one is MySQL. MySQL also completely managed by the Oracle only. So the vendor of MySQL as well as SQL is completely Oracle. And the next one is PostgreSQL. PostgreSQL. This database is completely based on OOPS plus DBMS. Okay. And the next one is we can go with MongoDB. So MongoDB is nothing but NoSQL database. NoSQL means not only SQL. That means without schema also, like we can store the data, we can retrieve the data and all. That is called as the MongoDB, NoSQL. So now we are focusing on MySQL. SQL, MySQL, PostgreSQL, the queries will be same. One or two maybe syntax related to syntax it may be changed, but remaining everything is same, right? So DDL is nothing but defines, alters, and destroy physical structure of the database objects. So example, the commands under DDL is create, alter. Let me write in capital letters, but you can write in small letters also while writing the query. Alter, drop, truncate, and rename. Rename is used to rename the table. The next one is DML, data manipulation language. Data manipulation language. Data manipulation language. So DDL is more of DDL will not be linked with the data part. It will be only focusing on the table part only. Table defining a table, altering the table, and a drop the table. Simple, simple. And here it is going to manages and modifies the actual data rows stored stored within the table. So it is going to manipulate the data. It is going to modify. We are going to add data, delete the data, select the data, and update the data. So let me go with first query is insert, update, delete. Uh, Here, instead of writing 5 commands, simply people will use these 3 commands also. Create, alter, drop. I'll tell you what is create, alter, drop. What is the purpose of create? What is the purpose of alter? We'll see clearly in the next topics. I'm only giving you the definition and the example commands. In simple, we call it as a CAD. CAD is nothing but create, alter, drop. Coming to this insert, update, delete, right? Some people will write select also, but some people may not write that because DML is nothing but it is a manipulation of the data. Like you can insert, you can update and delete also. You can see in some resources, you can see select also in the DML. Otherwise, for select exclusively, we have third one that is the DQL. DQL or DRL. We call it as data query language or data retrieval language. Retrieval language. Data query language. It is going to retrieves. It is going to only perform display operations. Retrieves data rows from the database. From the database. So the example command is select. So people, you can see some resources, as I said, like select also will be part of DML, but people, if anyone asks like why select, you can say it as DQL and DRL separately a select statement. Okay, both are both. You can go with anything, no problem. DCL, DCL is nothing but data control language, data control language, data control language. It is going to manage the security. As I said, it's not about only handling the data. We need to manage the security also. That is very important because your entire application data is going to store in the database. System roles, like who is going to get access and who are not, and access controls. Roles, access control, admin, user, like different roles will be there, right? Not every person will have all the access, entire access. Some people will have limited access, and some people will have unlimited access. So the commands we have is grant. Grant is nothing but to assign the permission, to assign the specific permission, and revoke is nothing but whatever the permission you have given, you can withdraw it. The last one is TCL, transactional control language. Transactional control language. So it is going to manages the transactions, processing, blocks to preserve strict data integrity. So transaction is all about how you are going to handle the data, the consistency, and the recovery, everything and all. Example. So example commands are commit. Commit is nothing but whatever the work you have done, you need to save it permanently. In MySQL, auto commit is there. That means you don't need to commit the data manually. Whatever the query you perform, whether it is insert or update, that will permanently save the data. Okay, you don't need to commit the data manually. I'll show you these commands at the end of the session. Rollback. Before going to rollback, let me talk about save point. For example, I inserted 2 to 3 records. I created one save point. That is a version 1. Like that, I created multiple save points. For example, I want to go to previous version. That version is called a save point. So if you want to go to previous versions or restore the data, then it is nothing but what? Rollback. So commit is nothing but saving your work done permanently. Save point is nothing but creating versions. Okay. At the first moment, I created 3 records. Next moment, I deleted 1 record. I updated 1 record. Next third, I inserted 5 more records. Like that, there are multiple versions, right? Each version is called as one save point. If you want to go to previous versions, like previous points, you can restore to that point by using rollback. Like it's like a restore, right? Perfect. Now, I want to highlight like differences between drop versus truncate versus delete. And I just want to highlight one point that I didn't write I have written truncate in DDL. So what is drop versus truncate versus delete? So drop command, this command will delete entire data entire data in the table along with the structure also. Structure is called as schema. Entire. For example, the command is will be like drop table name. Okay. Next one is truncate. This command will only delete the entire data means all records. All records. This command will only delete the data like all records, but not schema. The schema will be there. The structure will be there. The table will be remain same. That means the table will be. That means the table will remain exist, but not the data. The third one is delete. Delete. Delete is nothing but this command will remove specific. The command is like truncate table. I'll show you every command in the demonstration. I'm just giving you the out the the objective of every command. Specific remove specific rows. Rows means records. Matching. So whenever I just want to delete two records, three records based on the condition like location, age, something like that. So you have to write some matching condition that is called as where condition. Matching a condition filter. Matching a condition filter. For example, uh, let me write a query like from delete from table name, where we are going to write where some condition here, condition. There is very, very important note point, delete command without where condition. Very important interview question, without where condition. For example, I forgot to mention you can see a lot of reels on the like kind of intern reels, generally people will do delete operation without putting where condition. So delete command without where condition means delete from table name. Directly delete from table name. You can use capital letters, you can use small letters. Don't worry. Delete from table name is same as truncate command. Truncate command. That means the table will be remain same. There is no dropping of table. Only data will be deleted. So very important question. If you want to drop table and the entire data, go with drop. If you want to delete only data but not table, go with truncate. If you want to delete like only few records or rows, then go with delete operation. The next one is data types. Let's talk about data types before going to proceed with the demonstration. You need to go with the data types. So the first type of data type is numeric data type. Numeric data types. The first one is integer. Int and integer. Int and integer is something like a standard integer, I can say. It is a standard integer. Generally, it uses 4 bytes. 4 bytes. 1 byte is equal to 8 bits. Next one is big int. Big int, it is a large integer. Large integer. Generally, it uses 8 bytes. Next one is float. Double. We call it as floating point numbers for floating point numbers for approximate decimal values. After dot, you can put decimals, two decimals or three decimals like that. Next one is very important, decimal of p comma s. This is fixed. You can decide your decimals after dot by using this data type. Exact numeric type. What is p? P means precision and s means scale. I want to highlight another point that p is equals to total number of digits total number of digits, total number of digits, whereas D is nothing decimal or yes, some people will call it as D decimal or yes scale. S is the number of digits, digits after the decimal point. That means after dot. When you want to deal with the financial data, people will go with decimal. For example, if I take decimal of 10 comma 2, 10 comma 2, 10 plus 2 is nothing but P, and 2 is nothing but S. S is nothing but what? Scale. Sometimes, sometimes S is also called as decimal. Okay, decimal. D means D. Scale is also called as D. That means decimal. P is not just only only 10. P is nothing but total number of digits before dot and after dot. S is nothing but after dot, right? The next type is character and string data types. The first one is char of n. We need to mention the size also, which is a fixed length, character string, character string. Trailing spaces. What are the trailing spaces is there? Trailing spaces will be padded to the length n. Faster for fixed. If you think your data is fixed, your value is fixed, it is not changing like anything, then you go for the char. Fixed size entries, it is recommendable. Example, if you want to store any kind of states or like countries and all, like gender, people go with char. The max size is 255 bytes. Varchar of n. Variable length, of course, varchar is variable length. Char is nothing but character, where varchar is like variable length character. String up to length n. N is a size. Only uses storage for the characters. So people will say, like, for example, the data type size is 10, for example, char of 10. Now you want to you have stored a value of size 5. So remaining five values, five spaces will be unused. But in variable, whatever the data value I have given, based on that data length, it'll consume. It will not waste the space. There is a difference between varchar and char. Only uses storage of the characters entered plus plus an extra length prefix. Extra length prefix. Prefix will be considered. Generally for username, email addresses, if you want to give any kind of names, text inputs and all, you can go ahead with this. And like the max size is 255 bytes. 255. It's not bytes, sorry. There is a one mistake. 255 characters. Here also max 255 characters. Next one is text slash long text, used for large blocks of data. When you want to store description or kind of a big data like multiple lines and all, like you can store by using this data type blocks of text data, product information, links, everything and all, right? The next one is date and date and time data types. First one is date. The storage format will be 4 wise, 2M, 2 TDs. Next one is time, hours, minutes, and seconds. Next one is date time. First date will be stored, followed by time will be stored, hours, minutes, seconds. Next one is timestamp. Timestamp stores internal epoch seconds. The date, the entire data, the date and time will be stored in the seconds. So we have to convert converts from the application's current time zone. What are the time zone we are like IST or Greenwich? What are the time zone? Based on that, we need to convert that into that time into actual time zone to UTC, UTC for storage purpose. Storage purpose. So the timestamp will be given as a seconds actually. The entire date time will be converted as a seconds. We can calculate. So based on the seconds, what are the seconds is there? For example, seconds 45, 45. This is the timestamp. So this we can, for example, let me just convert timestamp to date and time, for example. So now you can give this value. So so this is the current timestamp. It is showing the current timestamp, right? 178 like this. So whenever you convert this today's date, so this is the complete timestamp in the seconds as step seconds, milliseconds, and it is supporting microseconds also. Like so that seconds, what are the seconds that have that is completed till now? So will be converted to the date and time, which are the format you want. Right. And the next one is integrity constraints. Integrity constraints, very important constraints. Constraints are constraints are structural rules enforced on the data. On data, data means like mainly on the columns to protect data purity, purity and consistency. Like I can say constraints means conditions. Like I just want to allow null values. I don't want to allow null values. I want to keep my column as unique. I want to keep my column as not unique. Like that, I want to impose or enforce some conditions on my columns. Table contains rows and columns. First, we need to put the constraints on the columns. Accordingly, the data will be stored. My first constraint will be not null. It prevents a column from storing a null value, storing a null value, null value. That means not null means mandatory. Next one is unique. Every row, every row, that means the column value must be unique, or we can say distinct, distinct or unique. Example, email ID, contact number, username, etc. And I want to highlight one important point that unique will allow null values. Unique will allow null values. Yes. Whenever you keep unique constraint, of course your value must be unique. Your value must be unique, but the point is your value must be unique, but it will allow null values. If you give value, that should be unique. If you don't give value, that means you are skipping the value. Null value will be considered in the unique constraint. Next one is primary key. Primary key is nothing but Let me just talk about key first. Key. It is a it is a it is a it is a one column. Column means attribute. Don't confuse. Let me write one point. Column is nothing but attribute. Attribute. Key is nothing but one attribute or more than one attribute to uniquely identify the rows in a table. Rows in a table. That is called as what? Key. So take one attribute like ID. Take two attributes ID plus name. Like that, either one, if there are multiple columns in your table, so I have to pick up one column to identify one single record directly. But if you if you if you're taking one column, if you're getting 2 to 3 records, that is wrong. Okay, you need to uniquely identify. So under keys, we have first key called as primary key. Primary. So primary key is nothing but it is going to uniquely, as I said, uniquely identifies each row. Automatically, I just want to highlight one point. Primary key is nothing but there are two constraints will be involved. One is unique because your value will be unique and it will not allow null values. Primary key will not allow null values. Primary key will not allow null values and it will allow unique values. Val- values. And only one primary key is permitted per table. And I want to highlight one point. Primary key, for example, if I take primary key is nothing but student ID. ID is my primary key. Let's take a candidate key, for example. This is also primary key, but candidate key means along with one, I am going to take second one also, student ID with student name. Student name. And I want to highlight one important point that every key, that means irrespective of number of attributes in it, whether one or two, is a super key. Is a super key. Every key is a super key. Primary key means one attribute or one column. Candidate key means two columns and so on. But every key is a super key. The next one is foreign key. Very important. Foreign key. It links records between two tables, two tables, eh, two tables. It links records between two tables by ensuring value by ensuring value match the primary or primary key value of a primary key of a parent reference table. Parent reference table. Parent reference table. For example, department is a parent table. Employee is a child table. Here, department ID is my primary key. Here also department ID will be there, which is a foreign key. So this foreign key is going to refer the primary key in the department table. So we ensure that foreign key values matches the data in the primary key. And very important note point that foreign key will allow will allow values must be matched with primary key and foreign key allows null values. If you don't want to give values, you can skip. If you want to give value in the foreign key, that should match primary key. I repeat once again, foreign key will allow null values. And the next one is check. Next one is check. Next one is check. Next one is check. Check is nothing but it is going to enforce specific logical valuation logical valuation boundaries. Example, for example, there is a column called as salary column. This is one of the column in the table. I want to insert values more than 10,000. So what I'll do is like check off, the column name is salary greater than 10,000. So only 10 greater than 10,000 values only will be considered. I'm going to show this demonstration in the queries default. Like this, another example, I want to insert age with more than 18 only. So age with 18 only. Then we can put this kind of constraint. So that instead of giving any random data, you can give a specific values only. Default is nothing but sometimes we need to like fix the value. Like I want to fix the value as 0 directly for all the columns. Not all the columns, for all the records, this column value is 0. Or for all the records, this column value is password same, KLU123 or Surya123, like that. So automatically injects a predefined value, very important, predefined value is a correct word, predefined value when, when no data is provided. Example, let me take price. I want to give a price value as 0, by default value as 0. Or I want to take status as active. Or I want to keep my password as everyone, for everyone, the password should be like something like demo123, demo123. So for string, we can use single quotes or double quotes, no problem. If I don't put string means the value, the value will be enclosed using single quotes or double quotes. Double quotes. Without single quotes, double quotes means like it is called as a what we call number. So that's all regarding introduction. It's we completed nearly 1 hour, like where we discussed about the introduction part. First, we need to be ready with the what we call the installation part of MySQL and PostgreSQL. We are going to demonstrate everything using MySQL. I discussed about what is data. Next one is information. Next one is relationship between data and information, and then database, DBMS, and then uh, DBMS means file storage. RDBMS means tables, and there is a relationship between tables also using foreign key. Constraint means condition. What is table? What is row? What is column? What is degree? What is cardinality? What is SQL exactly? What are the CRUD operations? Uh, what is query basically? Query is nothing but a question that we are going to ask by using in the format of SQL. What are the different types of sub languages, or we call it as database languages? DDL, DML, DQL, DCL, TCL. Next one is drop, truncate, delete differences. And then data types, numeric type. Next one is character type. Character where char means fixed, where char means variable. Like in the char, the extra space will be unused. So data wastage will be there. The space wastage will be there. In varchar, how much value length will be there? Up to that, it will be stored. Okay. Text or long text for the product description, for the description, for the comments, like large lines, if they are there, that this data type will be used. Date time, integrity constraints. Constraints means not null. Constraints means conditions, not null. Unique will allow null values. Key is nothing but one attribute or more than one attribute to uniquely identify the rows in the table. Attribute means column, primary key, foreign key, check, default. Then fine. So let us all start our demonstration. Now you need to be ready with MySQL software with the demonstration. So I'll do two types of demonstration. One is like command line prompt, and the second one is like MySQL workbench. So let me just open MySQL command line client. MySQL. You can see this demonstration in my episode 2, sorry, MySQL and PostgreSQL database installation. Shown you, I clearly shown you the demonstration of how to download and install MySQL and PostgreSQL, how to access the MySQL. Please watch that episode clearly. Like if I show you the installation again, it will it will waste the time. So please watch that episode completely. Uh, 1 second. Enter the password root. My password is root. You can see this demonstration clearly. Like I've shown you, I've shown this entire demo, like how to open MySQL, everything in my episode 2. Please watch that episode 2. Now, first of all, we need to create database. So for the creation of database, create, first we need to check whether database is there or not. For that purpose, for that purpose, first drop the database if already exists or not. So drop database if I'm going to type every command in capital letters only for the understanding purpose, but you guys can, let me just put a note point here. You can use keywords, keywords in either capital letters or small letters while typing the query. Okay. So you can try also, no problem. So drop database if exists. So the first query will be like we are going to check whether database already exists or not. That is the first query. So I'm going to check. My point is like I'm going to create a tech kind of corporation database. So I already prepared with the data, everything and all, because I don't want to enter like random data. I prepared one database with all the data, not queries and all, only data with the 10 to 15 records. I'll use the same data. So corporation DB. So this is my database. So the point is like drop database if exists. So no rows got affected because this database is not there. So let's all create the database. How to create the database? Create the database name. The database name is create database. The database name is Tech Corporation DB. Right. Database got created. After database creation, we need to list out all the databases that we created so far. Show databases. Show databases. So these are the different databases we have like this. Even if I give some letters are capital, some letters are small, all database names will be taken as a small letters only. And then, so we need to select the specific database. For that purpose, use space database name. Use, what is the database name? You can use either capital letters or you can use small letters also. Let me go with small letters only. Corporation DB, Tech Corporation DB. Right, database is selected. So the first one is drop database if that database exists. Then one is create database and select the database, and now check whether tables are there or not. For that purpose, show tables. Show tables. So sorry, here I need to give show tables. There are no tables. Now let me show you how to create a table. So what I'll do is like, let me continue the same thing in the MySQL workbench so that it will be more visible, and the readability also will be very easy. The same commands I'm going to execute in MySQL workbench. In my, I've shown this in my, I've shown this in my previous episode, like episode 3, right? Now, if I remove this tab, you need to choose this SQL. So new, at the end, you can save this file also like this. Okay, .sql file. All the queries will be there. Here, existing table, yeah, Tech Corporation DBs. Just refresh if the database is not there. Yeah, now. Now, if you see this table got highlighted in bold, this is not because we need to set as a default schema. So set as default schema. Now it is showing in the bold color. Otherwise, you just choose the command called as use demo DB. For example, use demo DB, use demo DB. Select this and execute this. So now it is showing bold color. So either you right click on it and choose set as default schema. Schema is nothing but table, or you can just use the command called as use space database name. Okay. Now it is showing bold color. So either you right click on it and choose set as default schema. Schema is nothing but table, or you can just use the command called as use space database name. Okay. Let me just increase the MySQL workbench size so that the queries, everything will be visible clearly. Let me put edit, references, fonts and colors. For example, if I give 20, let me give 30, script shell, let me give 30. Let me close this and open MySQL workbench again. Click on this connection. Perfect. So I just need to close and reopen. That's why it is not reflected before. Fine. So now so now the current database is Tech Corporation DB. You can use this command again, Tech Corporation DB. So it is selected. Okay, perfect. Now you can just write the queries like this, like one after the other. Now let me create a table. So how to create a table? The table creation will be like, you can just use show tables option. So here semicolon should be there, semicolon. Select this. So no tables are present. Let me do one thing. Let me decrease the size. I given up to, let me give up to 15. Fine. Okay. Let me close this. Open MySQL workbench. This is fine actually. Right. Now let me just create table. How to create table? Create table. Let me create a table name as departments. Departments like this. So you need to give semicolon. So the syntax will be, first we need to mention the column name. After mentioning the column name, we need to mention this data type. So data type I'm taking int. For number data types, we need to mention the size. So just int, comma. The next one is department name. I'm taking varchar a size of 50, and I want to mention constant also, not null. That means like I want to make it as a mandatory column, mandatory column. And the next one is location. Let me take like string column. let it allow like null values. And the next one is I want to add constraint also primary key. Some people will add primary key directly here also, primary key like this, not null like this. But I want to add primary key separately. There are two ways. You can add constraints can be added in two ways, three ways actually. Constraints can be added in three ways as per my knowledge. The first one is the first one is you can add constraint near to the column while table creation. You can add constraint at the end of the at the end of the at the end of all columns while table creation only creation. And third one, last one, you can add constraint after table creation also. That means you forgot to add constraints. You want to add after the table creation. So after the table creation by using alter command, right? So we'll see all these such cases. Now I want to add constraint like this. Let me give constraint pk. Pk is nothing but primary key. So let me take department. Let's just use all small letters without any confusion. Departments. So because primary key for departments table, primary key, the primary key is department ID. Right. Or sir, I don't want to add like this. Can you just tell me a simple step? Yeah, yes, you can. You can directly add like this primary key. No need to write a separate line. But this will be very I mean this is very important step because if you keep a name for constraint separately, you can alter it or you can modify it or you can I mean alter or modify or you can delete this directly. Delete this. So my recommendation to is like even in software industry also constraints will be added like this only with a separate name. Okay, pk underscore departments is a constraint name. Okay, don't give the constraints directly here. Okay, because we have to alter and we have to delete them directly. I can delete them those constraints only without changing my schema after table creation. Okay, so just select this and click on like create table is done. Now show tables. Show tables. Now one table is present like this. So we with this we have done a table creation and I'm done with the what we call like how to create table also. Now let me create another table which is a employee table. So the first one is done. Next one is create table employees. Like this, you give the syntax employees. First one is employee ID, integer. Next one is first name, varchar of 50, not null, not null. And last name is varchar of 50, not null. And let me give age. Age is nothing but integer. Salary. Let me give decimal. We already discussed that decimal of. So 10 is nothing. 10 p comma s. P is nothing but 10 plus 2. S or D. Scale or decimal is nothing but 2. Next one is department ID, not null. Department ID is a number, right? Sorry, integer. Manager ID, integer. Hide date, which is mandatory column, not null. Status, whether it is active employee or not. 15 I'm going to take. Default value is active. Default value is active. Initially, whenever we insert the record, the status will be active. Let's add constraints now. The first constraint is pk underscore employees. Primary key I'm going to impose. The primary key is employee ID. Next constraint is check constraint. Check employee age. Check off if age, we are checking whether age is greater than equal to 18 or not. Less than 18, the value will not be checked. And the age should be whether age is null or not. Very important. Age is null. So either age is null and age greater than equal to 18. Next one is I think age. We didn't put a constraint called as null or not null in the age. Okay. constraint pick. Otherwise, let's just keep only a simple constraint like age, whether age should be greater than or equal to 18. Better, right? Why we need to check? That's enough. That's enough. Next constraint is check underscore employee salary. I want to impose the problem is like I didn't put a not null constraint here. So like this, not null constraint. If I put a not null constraint, then we no need to check like is null or not. So let us all directly keep this not null here. Better. Or let's not keep here and age should be greater than or equal to 18 or age is null or not. Null. So salary must be greater than 0 or salary is not null. Is null means whether null value is there or not. Not null means whether whether null not is not null means only null values will be omitted. Is null means null values will be displayed. The next constraint will be foreign key. How to write the foreign key? The foreign key constraint name is foreign key employee department. So foreign key is a child column. Foreign key is a child column. Foreign key. What is a foreign key? So in this table, I'm going to take foreign key child column as department ID, which is going to refer the parent column department ID. What is the parent references? What is the parent table? Departments. Departments is my parent table. In that, what is the primary key value? Department ID. So this is how we have to create table and check constraint, everything we can just take. If you give not null directly here, you don't need to check whether age is null or not separately because I didn't mention not null because I initially uh, I've taken as a, I've taken as a like optional field only, not as a mandatory value. So there, just select all the entire syntax and click on so I just got one error, failed to open reference table. Let me just department spelling. Yeah. Now let me just select this. The table got created. Now let me just check what are the tables we have. The query is already available, but let me just type again. Flow tables with semicolon. Two tables got created. Right. Perfect. Now, so let us all insert the data. Let us all insert the data. So I'm going to insert the data, insert into, first we need to complete the parent table because child table depending on parent table department IDs. So insert into table name parent table. So let's just mention the department ID. Let me just highlight one important point that in my department table, first one is mandatory because primary key will allow unique plus not null. So department ID is mandatory, department name is mandatory, and the location also it's not mandatory. You can skip values actually. Let's see. So I'm mentioning the column names also. So departments. You can directly give department values. This is the query actually. Insert into table name department values. The structure is first one is ID name. So let me take ID as 10 and let me take department name as for example human resources department and let me just give the location as for example New York. Okay, so this is the query. So this is how we have to insert the record, insert into table name values and every column value. You know, you can skip the location also because location is not important. Okay, for example, let me give insert this. So it is done. Now let me just insert the same one with the 20. I want to skip the second one. Location is not important, right? Because it's not a mandatory column. And let me give the department name as engineering engineering. So let's check whether we are going to get error or not. Error code because the number of columns in the department are three, but we are giving only three values. So two values. The third value is not mandatory. In that situation, we need to mention the what we call the column names. For which columns you are giving the values, that is very important. So I'm going to skip third one. That's my wish because it's a null value. Let me just check what exactly we are going to get. Inserted. So because third is a null, location is null, right? Because you can allow null values because you didn't put any not null constraint, right? So let me insert, I think I inserted two records as of now. Let me continue to insert remaining records also. Let me just insert the records in a bulk mode with a single insert command, departments. So what exactly I want to insert? Department ID, department name, and the location values. Two records are inserted, 10, 20. Let me continue. Next one is 30. The next department is data science, and the location is Seattle, comma. The next one is 40. The next location is marketing, Chicago. Next one is 50, operations, Boston. Right. So three more records got inserted. Right. So total five records. So without any further delay, let us all insert the records in the employee also. Insert into, what is the table name? Employees. Let me start mentioning the column names, employee ID. If you if you are inserting for the all the values, no need to mention the columns. Okay. If you insert for the only few columns, please mention the values. And if you want to insert values in different order, in that case also you need to mention the column names after table name. Employee ID, first name, last name, age, salary, department ID, department ID, department ID, and the next one is manager ID, hire date, and status. Let me just values, status and values. I think status is taking as a keyword, right? Okay, let's check whether it's going to execute or not. If there is any other, we can alter that, no problem. One comma. Let's take Amit. You can take single quotes or double quotes, no problem. Amit. Last name is Sharma, 28, 85,000. After dot, we need to put two zeros only, two decimal, two zeros are 1, 2, 3, 4, 5, 6, 2, up to 2. That means up to 99 we can take. 20, age. No, no, no. 1 second. 28 is age, salary. Department ID is 20. Okay. Null. Manager ID is null because this employee is not manager. Okay. Manager ID is null. This employee is not a manager. That's why. If you see manager ID and the employee ID both are same, that I mean, same or different, that means, for example, one is the employee ID, two is the manager ID. So for this employee, two employees the manager, like that. Null. Then next one is hire date, -01 in active. Like this, we'll insert total 10 records. So what I'll do is, like, let me copy this. This 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now let's change the values, like Priya, second one. And the next one is Rahul. Next one is Sneha. And the next one is Vikram. Next one is Ananya. Next one is Rohan, Neha, John, Jane. These are the first names. Let me take, I need to put a single quotes. Yeah, that's the problem. Right. Null active single quotes. Next, let us all change values. Here also, I just forgot to include single quotes. Here I can just mention semicolon. Right, no errors. Now let's change the values like Patel. Next one, Varma. Next one, Reddy, Sneha Reddy, Vikram Singh, Ananya Iyer, Rohan Das, Neha Kapoor, John Doy, James Smith. Let's change their ages because I'm following the order. For example, if I keep age after salary, then you need to change the values. You can change the order also. That's up to you. You don't need to follow the column order. That's up to you. 32, 24, 29, 35, 27, 31. You can put everything in Excel and you can import also if you want. We have data import export options also in the MySQL workbench. 26, 40, 22. Now here 1,20,000, 60,000, 95,000, 1,40,000, 55,000, 72,000, 68. Next, let me keep salary as null. So I don't want to keep, I want to keep null value for the salary for the ninth record because it's not mandatory, right? Now the last one also null. So two values are null. Okay. Salary is completed. Let's go with the age is salaries and department IDs. 20. Let's take 30. This employee belongs to 30, third department. 20, 30, again 30. For sixth record 10. For seventh record 40. Foreign key will have null values. Let's take null value. No department ID. You can still take that. Next one is 20. And these also I want to keep it as null. No department ID. So foreign key will allow null values. Next one. Status will be active only. Let us all only change the hire date. Coming to hire date, this is 2021 6 10 24 3 1 23 8 11 19 5 20 19 5 20 25 1 10. That is the sixth record. 23 11 15. The status is on leave. 24 7 19 active. Next one 25 5 12 active. Next, finally, last record 26 201. Right. So total 10 records. Let's insert this. Let's check whether I got one hire date. Unknown column hire date. What is the spelling of hire date? Date. Oh, I've given data. Okay, we'll change the column name later. No problem. Okay. Incorrect date value. Like I given 110. It's 10. Salary can't be null. For which column salaries can't be null? Like first one, salary can't be null. Yeah, perfect. Salary should be salary. Check salary is greater than zero and null. Okay. So for the record, salary is a 1, 2, 3, 4, 5, fifth value. We got error for salary, right? Because we are checking is null constant or not. Yeah, it should be greater than zero. Set constraint we have imposed, right? Yeah. So for that purpose, let's give 34,000.00. Again, we'll check whether we'll get the same error or not. Same salary can't be null. Yeah. So because it should be greater than zero, where you mentioned 78,000.00. 10 rows affected. All 10 rows got inserted successfully. So we imposed like a constraint called as salary should be greater than zero and should not be null separately. As I mentioned, if you want to remove this, you directly mention not null here itself directly. Here you can directly mention. Oh God, I think I mentioned not null. Let us all see the description of the table clearly. So we'll get to know whether I mentioned not null or null. DEC space departments. First, let's check the departments. So location only S null. Employee employees DSC space table name. That is a here employee ID not null because it's a primary key. First name not null. Last name not null. Age yeah. Salary null no. Yeah, because I given not null, right? That's why it is not allowing null values. That's the problem here. Okay, no problem. No problem. Right. Initially, I thought of not taking the value, but I taken not null. Okay. So in that case, you no need to mention. I mean, you no need. You can directly put age greater than equal to 18 condition, salary greater than zero. Or salary greater than 10,000 also. Only more than 10,000 values only will be taken. You can go ahead, you can experiment in that way also. Now let's take the alt, I mean like I just want to use alter command. Alter table employees is my table name, right? Let me rename to corporate staff. Corporate staff. Let me just run this. Run. Let's check the tables whether the name is changed or not. Yes, name got changed. Let me just rename again to employees. I I want to proceed with employees only instead of corporate staff. Rename to employees. Let me run this. Let me run this show tables. Yeah, perfect. Now you can change the column name also. I think alter table. I think hide data, right? Okay. In the employee tables, one of the column name is wrong. So alter table rename column hide data to hide date. Right. This is the rename in the column. Right. Let's check the description. Description employees. Let's check whether it's changed or not. Yes, it is changed. Perfect. Now, first name, Alter, I want to remove not null for salary. Alter table employees, modify column salary. I want to remove not null for salary. Varchar of 150. Let me take, I think it is decimal, right? Let's take, it's not varchar, decimal of 10 comma 2, just 10 comma 2. Okay. This is one command I want to execute. I don't want to put not null. We'll see what will happen. Executed. Now let's just check the description of the employee table. Null should be yes. Previously it is no because I given not null constant. Now I removed that. Okay. Now I removed that. Like the same, let me just modify. Let me keep not null for first name. I think first name is null. First name is null or not null. Let me not null only. But let's change the varchar. I think it is 50, right? Let's take varchar of 100. Don't forget to mention not null because previously it is not null only. If you remove not null, the problem will be uh, it will be considered as a null semicolon. Then description. So not null is there and change it to not null. Perfect. And now let me insert one record. Initially we got error for null because I mentioned not null and I'm trying to give null value. Let me just check with the null value now whether it is going to take or not. So insert into, I think we have to mention the entire query. Okay, 1 second. I'm not inserting all the records, just one record only. I'm just only copying the syntax for reference. So let's not put everything, right? It is 11. Let's take Surya and last name as Kiran, age 25. Salary, I want to keep it as null. Department ID, I want to keep it as null. Manager ID, I want to keep it as null because it is null value only. Hire, here, now it is hire date, not data. Let me insert. Now check whether is it going to take null values. Salary is going to take null values. S is going to take because it's a null constraint. Perfect then. So we used alter command also to rename the table name, to rename the column name, and to modify the constraints. And then we checked what we call we modify the size also. Like that you can change the type also if you want, right? Let us all now adding and dropping the columns and constraints. Now, the next command is alter table employees, add column. Let me add a new column, performance rating, varchar of 5, AB, grade kind of thing. Okay. So default, my rating is, let me take B, varchar of. Let me just execute multiple queries at a time. Alter table employees, next one. Let me just drop the column performance rating. Next one, performance rating. First, let me execute this one. Added. Next, let me check the description. Check whether it is there or not. It is there with the default value as B. Perfect. Now let us all drop it. I don't want that. Alter. Okay. Now let me just add constraints also. Now I added columns. Let me add constraints also. Departments. The constraint is add constraint. You you put a name for a constraint separately. It'll be a very good approach. Department name I want to keep unique constraint with department name. Okay. Here you need to mention semicolon. You can do all these queries in the command prompt also. Then the department spelling. Okay. Sorry, my bad. Right. The constraint added. I mean, I didn't add at the beginning. I mean, while table creation, I added like after table creation, I'm adding constraints. This is a very good approach, right? Instead of, because not all constraints will be added at the table creation, right? Some constraints will be added after the table creation also, right? Now, let us all add some more constraints like alter table employees, add constraint, add constraint. My constraint name is check employee status. Check off, check constraint. I'm adding the length, the length of the status. Status is active in on leave like that status. That length should be greater than equal to 3. Okay, not it's not not should be like 0, 1, 2. It should be minimum 3. Right. Check constraint. Then all 11 rows got updated. Okay. Right. Now, if I just want to add any record with the status as with a 3 length, then it will not be considered. Perfect. Now let's alter the uh, let employees. You can you can drop the foreign key also like this. You can drop foreign key. For example, what is a foreign key name actually we have given? So while table creation syntax, the foreign key is like this one, right? You can remove that, but I don't want to remove let's just let me just go ahead with that. I don't want to remove. Uh, let me let's do one thing. Let me remove this constraint like age constraint and let me remove this age constraint, EMPH. So we have a constraint name specifically, right? That is the power of having constraint name separately. Alter table employees drop. What is the constraint name? It is check, right? Check foreign key. Check alter table name drop check. Yeah, this one. So let me just check. It's got removed. Yeah, it's got removed. Now constraints got removed. Right. So this is how we can just add the constraint. We can drop the constraints also. If you want, you can add the constraints also. Like I already added like this one. Now let me. I think I removed the check constraint, right? Now let me just check the database and employees. For the which one I dropped? I think for the age. So there is no check constraint or default. I think age is not null, right? We'll do one thing. Let me add not null constraint for age. This is employees, add constraint, not null, age. This is not null of age, not null of age. Let's take like this. You can't add constraints. This kind of constraints we have to add by using this syntax, that is alter command. Alter command. I think we have done only primary key, foreign key, unique key because there is a space, right? So if there is a space, it will not be allowed. So we have to use this syntax like modify. So let's use this command modify. So let me apply not null constraint for age. Age. So age is like integer only. Here you put. Let me run this. If you want to give name, then the best approach is constraint, add constraint, modify constraint like that. Let me check whether not null is there or not null constraint came or not for the age column. Yeah, it is there. Null, no. Okay, like that you can apply for salary also, right? So, so The next one is, let us all say like operators, MySQL operator reference, operators. Let's check. The first one is arithmetic operator, operators. Arithmetic operators like plus, that is addition, and the next one is minus. Next one is into, slash, percentage, that is mod. Okay. Now let me just check the query. Now the query is, we done with the insert operation, and that query select star from departments. Select star from department. Star means all columns, all columns. So you can see all five. You can see like all five values are there, right? Right, five values. And like the same, let's all check. Select the statement is view. Star means all columns. So let me just write here. We have done with the create command. We have done with the alter command. Now we are seeing select command. Select star from table name, where star means all columns. If you want to display few columns, you can display. So for example, I want to display department ID, comma, department name from departments. Right. So only two columns will be displayed. Right. Like this, let me just check employees also with all columns. All columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. So almost, I think manager ID, like it is a manager ID is it. I think we given null for manager ID. Did I mention manager ID balance? No, I think for all records I mentioned null only. Okay, manager ID, right? Now next one, let me just check only few columns. For that purpose, I'll give ID, employee ID, and I want to see their age and the status from. Right, perfect. Manager ID is something like, as I said, like that manager is like that employee is a manager or not. If it is there, so that those both those columns are like match. You can apply self join within the table itself. If there are two matched columns, I mean, if two columns have same values, then we can apply self join, right? Now let's apply arithmetic operator. Select. Let me check first name, salary. I want salary should be. Before that, let me apply where condition. Select, for example, I want to view I want to view salaries where salary is greater than 10,000. So in that sense, let me just check the result output. Employees, right? Yeah, it's a where condition. These are the salaries like with it. For example, if I give multiple zeros, check whether how many records are going to display. I think no records, right? You can take status also, where status should be how many employees like with on leave. Status is equals to on leave, on leave. I think status is a keyword, it seems. That's why it is showing in a blue color. Yeah, it is still one record only. Let me just write one record like calculate a projected hyphen is for comments. 10% salary. That is a query actually. 10% salary. 10% salary. Bonus. And a flat 500 rupees deduction evaluation. Select. I want to display first name, salary, previous salary, and a salary with a bonus which is into 10%. 10% means 10 by 100, 0.10 as bonus. As is nothing but keyword. Bonus means alias. So salary into 0.10 is a new column, right? So new, not a new column in the table, like a separate column you're going to display with, I'm going to keep a name, which is a alias, bonus. And along with that, 50% deduction minus 100 as adjusted pay, a new value, alias called as adjusted pay from employees. So what exactly going to display? First name will be displayed, existing salary will be displayed, new salary will be displayed by multiplying with 0.1 as a bonus, and like salary with 500, what we call deduction will be displayed as a adjusted pay. Let me check this. So 85,000 is the 85,000 is the salary. Bonus is 8,500. Adjusted pay is like minus from the previous salary, because I'm not going to update the bonus salary in the table directly. I'm only displaying. Like now, for example, I want to show this only for the salaries more than 1 lakh. Salary more than 1 lakh. There's a one error. Let's check the error here. Oh, it is showing. Let me just run this. More than 1 lakh is two salaries are there. More than 1 lakh. Remaining and all less than 10,000 only. Perfect. You can save this record like desktop queries, so that every time we can execute. The next one is comparison operators. It's 4 o'clock now, like 3 minutes to 4 o'clock. We completed 2 hours, so the session will be continued. Comparison operators. Right. Comparison operators like equals, not equals. This is also not equals only. Greater than, less than, greater than equal to, and finally less than equal to. These are the different comparison operators. So let's just check that here. Find employees earning. I think already seen this. Let me just check again. 90,000. Select star from employees where their salary is greater than 90,000. Let's put semicolon. Then there are totally 3 records got displayed. The next one, comment. Find employees. Find employees who don't belong to department 20. So in that sense, it's like a not equal to. Yeah, less than greater than is something like not equal to. So not equal to 20, you can write. Select star from employee where, for example, department ID not equal to 20. So employee, so those who are not part of 20, that means remaining department employees will be displayed, because we have 5 departments, 10, 20, 30, 40, 50. It is employees, right? Total 5 records. Instead of that, you can take this symbol also. Same 5 rows will be displayed. Perfect. So I just want to highlight one point, not equal to or less than, greater than, both are same. Next, to logical operators. Logical operators means and or not. and that means and is something like both conditions must be true. That is something uh, like true, true mean like it's true, false means false. First condition is true, second condition is false, false. First condition is false, second condition is true, still false. First condition is false, second condition is false, still false. Both conditions are true. This is nothing but true. Or is nothing but like same, but if one of the condition is true, that's enough. So true, false means true. False, true means true. False, false, false only. It is true. Not means if it is true, for example, it is going to be false. False is going to be true. Now here, the query I'm going to write is find employees in department 20 earning over 70,000. Select, so department 20 and we should print more than a salary more than 70,000. Perfect. The two conditions I need to impose. And or like conjunction operator, right? Where department ID is equals to 20 and salary is greater than 70,000, semicolon. So salary should be only one employee where his department ID is 20 and his salary is more than 70,000. Perfect. Let's go with another query. Find employees who are in either department 10 or 40. So I either 10 and 40 is not possible because one employee will work in one department only as per our data. But if you want to keep one employee with multiple departments, then under will be okay. But as per the data only, queries will be executed, and it's not. And your query must be applicable to the upcoming data also. You can't write the queries only based on the existing data. 10 or 40. So employees may work in department 10 or employees may work in department 40 also. So the query is where department ID is equals to 10 or department ID is equals to 40. Right, right. So like this, we have totally two departments. Okay. 10, one employee, 40, one employee. The next one is special range operators. We call it as between, like between and operator, special range, and set and null operators. Right. So let us all see some queries on these operators. The query is uh, let me just introduce a between operator. We call it as between and. Uh, that means, for example, select star from employees where age. I want to display employees with age between 25 and 32. So both 25 and 32 also will be included. So where age between between 25 and 32. So 25 and 32 also will be included. Okay. So greater than equal to 25 and less than equal to 32. Total 7 employees. The same query can be executed using comparison operators also by using where age is greater than equal to 25 and operator because both conditions should be true. So less than equal to 32. So let us all get this query. Same 7 records. Like, yeah. The next one, let me introduce a set operator. We call it as a in operator. We call it as set matching. In means we can give multiple values in the query. For example, uh, select a star from employee where I want to display employees who are working in either 10 department or 20 department or 30 department or 40 department. So department in of, we have to give values like this as a set. So there's a set of values. 10 in is something like multiple values with or condition, So it is employees. Every time I'm doing this mistake, employees, right? Five. And the same query we can write using or condition also. Select star from employees where department ID is 10 or department ID is 30. You can ask me one question, sir, can I write the same query with not equal to like 2050 because 2050 not equal to means employees will work in 10 30 40, but in future if I add department 60, so your query will not be workable. So based on the data and the future data also, your query must be written, not only based on the existing. So that like this, we need to mention the column name multiple times. So 5 rows. So this is very easy, simple. We can mention the values directly using in operator. Right. The next one is the null. So let us all check which column is null, which column is not null. Null. So using null operator. Select a star from employees where what are the columns where null values are there. So that is null. So there are some columns where salary is not there, right? Let us all check that. So 11th record where salary is not there. Okay. Next one. Let us all check for which records like salary is there. Is not null. Simple. We can use capital letters or small letters. So remaining 10 records will be displayed. Like the same, let us all check the same condition with department ID also, where department ID is not null. Is not null. So there are some records where department ID is not there and it is there. Eight records, eight records not null, three records null, three records. I want to uh, get their employee ID only, for example, instead of all columns, which employees having no department ID. So 8 to 10, 11, these three employees are not in any department. Okay, fine. So the next one is pattern matching. This is very important. This is very, very important. This is very important in searching also, pattern matching. Pattern matching like is something like operator. There are two characters we have to use. We call it as wildcards. The first one is percentage. The next one is underscore. So what is percentage, sir? For example, percentage means the length is minimum 0 to infinity. Whenever there is a percentage, 0 to infinity, zero characters or what we call I mean, up to infinity character. Length means one. One underscore means one length. For example, if I keep a percentage means starts with a. After a, any number of characters can be present. Star a means ends with a. Before a, any number of characters. Percentage a, ab percentage. That means ab as substring. So anywhere in your string, ab should be there. Before, after, any number of strings can be there. I hope it is clear. Next, a underscore. The first character is a and second character, second character. So a underscore means length 2 only. First of all, length 2 only because a and underscore one length 2 only, length 2. Second character may be anything. A underscore underscore means three characters. Second and third character may be anything, but it is fixed. It is fixed. For example, underscore a percentage. First character may be anything. Second character must be a. After second character, any number of characters. And one more thing, let me just give you a tricky one. A underscore percentage. Underscore means minimum one. Underscore means one and percentage. That means minimum after a, uh, before a one character for sure. After a After a, if only percentage is there, any number of characters, maybe zero also there. But we mentioned after a one underscore percentage. So after a minimum one character should be there because we mentioned one underscore. One to infinity because percentage is there. So let us all check these queries. Pattern match. Select star from employees where first name like operator pattern. So a percentage is nothing but pattern. Let me give capital letters a percentage. So it starts with a. This is nothing but what? Starts with with A. A. First name starts with A. Total two records. Perfect. The next one is the same records. Let's take a last name with SH Sharma. Okay. Let's take let's take the same with end with A. First name end with A. We'll see what are the records we are going to get. Let's take with IT. IT. First name only I'm checking. You can check with another other also. End with IT. Anywhere in the first name, A should be there. So there all 10 records. U should be there, first name. Two records. Perfect. Next query, same with three length, three underscores. That is three underscores. Nothing is there. Five underscore, that means five length strings. Right. Next one, next one. You can keep here not like also, that is reverse of five length. That is other than five length string will be displayed. Okay. So like this, you can put not for the previous one also. Other than first name, other than five length. That means three length, four length, five, six length, like that. Here also you can mention not. Not. Right. Other than you, first names will be printed. So you can't find you. So like, not like. Like means matching, not like means not matching. Here, like let's go with matching last name. I'm just doing one query from employees where where username, not username is not the last name, like operator. I want this first character should be fixed, second character A percentage. That means first character should, second character should be A. Before that, one character will be there. That may be any character. After any number of characters. So basically, this query is something like it will take any length string where second character should be A. Right. Last name Patel Das Kapoor. Super. Right. So the next one is aggregate functions. Like this, we can do pattern matching. It is generally used for the searching operations. Whenever we give anything in the Google, that will be matched with the title, description, and all. So aggregate functions. Aggregate functions are also called as multi-row functions. Generally, where condition is for single row. It's a row-wise operation. Okay. Whereas multi-row is nothing but aggregate function is like multiple rows. Multiple rows will be combined, count, sum, average like that. It is going to give you a summary value. Okay, return a single summary value. So the operations are like count of star. Star means all columns. You already know that count of star. Count of counts every row. While every row it will be counted using null value also. While functions like sum, avg, min, max, and the count of a specific column name ignores null fields entirely. For example, if in your one of your records contains all null values, so if you go with count of star, that row entire row also will be calculated. But in count of column, if the column contains any null values, that will not be counted. Only not null values only will be counted, like sum, average, min, max also. So let us all see that. So select the count of star from total employees as total employees. Count of star is my total employee, that is alias, and the count of salary, because there are some null values are there, right? Employees with salaries from table name employees, because in salary there are null values are there. So 11, 10. Okay. So 11, all in salary, 11th record got null value. That's why it is showing only 10. Perfect. Next, select a sum of salary as total salary from employees. So it will, so 11 values are there. One value will not be considered because it's a null value. So total 10 values. So total 10 values salary will be printed. 10 value salaries. Okay. Next, select count of salary, count of average of salary. So null values will be omitted. Salary as average salary from employee. Right. Now select minimum of salary. Here also like null value will be omitted. Lowest salary, sal, max of salary as high sal from employees. Right. Null values will be omitted. Min, max, average, sum. Yeah. Next one is aggregations with grouping and paging and sorting. So let's go with grouping, pagination, and the sorting. This is very important in a web application because I want to restrict the number of records in every page. In Amazon, Flipkart, everything you say, all products will not be displayed in one page. For every page wise, the number of records will be omitted, right? So we have order by first one. Order by is nothing but it sorts resulting records records in either ascending order. ASC is nothing but ascending or descending. Next one is let me keep it as capital letters for visibility purpose. Next one is group by. Group by is something like identical arranges identical data rows into summary groups. It is used alongside aggregate functions to generate statistics for individual. So if you want to combine multiple, for example, I want to combine all employees in one single department, or department wise I want to get some data. For that purpose we have to use group by. Having having is nothing but having versus where is very important condition. Where condition filters data records before data records before aggregate grouping aggregate grouping calculations are computed. So where filter data records before records aggregate grouping calculations are completed. So where I just have to use a word called as before. Before aggregation, where will be where condition will filter the records, whereas having filters Summary rows, whatever the result released by the group by, we are going to impose a condition on the group by. Row wise condition is nothing but where, group by condition is nothing but having. After the group by group grouping process is finalized. Right. Having is more of like group by, where is nothing but row wise. Limit and offset. These generally used for pagination. Like example in Amazon, Flipkart, everything and all, you can see like number of products displaying in every page. So limit is nothing but it's more of it specifies it specifies the max rows to return. Offset starting position specifies starting position. Right. Let's check here. Select star from employees. Let's apply order by salary ascending order. ASC. I want to display all salaries in ascending order. Right. Up. Then same query. First, I want to display all salaries in ascending order, followed by age in descending order. Perfect. First, all salaries are order ascending order. First, null value will be there. If you want, you can. Uh, if you want to omit null value, then the condition will be where salary is not null. Right. Where condition should be written before order by. Yes. Then 10 rows will be displayed. Now salary is like ascending and age is nothing but descending. Perfect. Right. Let me implement duplicate distinct. Distinct is like we can eliminate duplicate values. All duplicates values will be displayed as a single value. So distinct department IDs are repeated, right? Because foreign key from employees. There are same department IDs. So will be grouped. You can see null, all null values will be grouped into one value. All tens will be grouped into one group like this. So if you want to omit that null, simple when where department ID is not null. So that null also will be, you have to execute the queries using null value. You'll get to know for which queries null is considered or for not. You have to, I mean, don't neglect the null value. So you need to experiment with the null values also. Now null value is omitted 10, 20, 30. Yeah. Now let's just use aggregate functions with group by and having department ID, count of star from, let me just count of salary. I want to count all salaries, all salaries from employees. Let me group count of salaries, group by their department. Department ID wise, I need count of salaries. Let's apply a sum of salaries. So let's check what will happen. So this is nothing but department wise sum of the salaries. Okay. So let me just mention department ID also. Yeah, null values will be omitted. There are totally department ID. This department is like null value, right? I think there are some null values here. So we can department ID, then let's display count also. Department ID and then count of star. If you want, you can use alias also. After count, I just want to mention count of salary also. Salary. Some I already taken. Let me just mention average also. Average of salary. Right. Average of salary of, let's check what, yeah, department ID, salary. With department ID, null values are there, right? Yeah. See, for the first record, whoever like department IDs are null, their count of star is 3. For I think for 3 records, out of 3 records, 2 records got salary. That's why count of salary is 2. Remaining record is null. That is 11th record. Sum is 1,46,000 and the average is 73,000. Perfect. Now let us all keep the condition on this. What are the values got displayed? So I want to have a condition like having. Let's keep a condition like this for understanding purpose. First group by, and the next immediate condition will be having. I want to print all the average salaries which are greater than 70,000. Right. If I want to, for example, now let me put department IDs also where I want to filter the department IDs with the not null, is not null. Right, right, right. So finally, 30, 40. For example, now let's remove this condition. First, let's all apply this condition. Now, first what will happen? First, is not null will be applied. Okay, as first, first where condition will be applied, then group condition will be applied, and then having condition. I'll write like at the end. At the end. So 10, 20, 30 department wise we have sum and average. So all null values also. These are equal now, right? Because null values we omitted. Now the same query, let's just execute the same query with having condition. So more than 70,000. This one and this one. Right, right. Now you can apply order by also, like order by. Uh, let's keep. I want to display department ID with DSC. Right, like this we can apply. So this is a query with like all kind of keywords. Let's apply offset everything. Offset and paging. Select the star from employees. Employees order by employee ID. Let me just take employee ID because it's employee table, like 1, 2, 3, 4. ASC, ascending order. I think it's same order, right? With the limit as 5. First 5 records will be displayed. Let me take 3, 4. 4 records will be displayed. You can see 4 records. Same query. Let's give offset for starting position 4. It's nothing but starting position offset. We are getting an error that offset is not valid position. Okay. Let's execute with the limit. Limit 3, offset 3. Offset 3. So now I need to display 3 records. Starting position is 3. Total 3 records 1, 2, 3, 4. 3 plus 1. So that means 3, 3 is nothing but the point here is like in the pagination, fetch page 2 records, assuming a 3 record page layout. If I give a limit 5, for example, 4, 5, 6, 7, 8, total 5. Let's take a 0. Offset 0 means 0 represents first record. Okay, fine. If I give 2, starts from third record, 3. Okay, right. So here offset represents index starts from 1. Next, very important concepts, joins. 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 So these, I think, with this we are going to this one and the next one is normalization. With this we can wind up joins. So what is joins exactly? A join links fields across multiple relational data tables using foreign keys, using foreign key references. Actually, how many tables generally if you want to join, if you want to apply join, we need at least one table. One table is enough. One table. That means that one table must contains two columns with compulsory two columns with similar values. Similar values. So matched columns. Or if if minimum two tables are there, if minimum two tables are there, then two tables must contains must contain a column with similar. So first table one column, second table one column with the similar values. Then we can apply join. Then we can apply join. So the first one is inner join. Inner join returns records that have returns records that have matching values in both the tables. Records without records without records without matching keys. Keys means attributes on either side or completely omitted. So not matching values will not be printed. Okay, omitted. So let's check this. For example, let me execute this query. This is completely join operations, very important. So join operations. For example, two tables, right? Select, let's take a star initially from two tables. First table is employee, employees, and second table is departments, departments, employees, comma departments. If I execute this, what will happen? So if it is, you can see like both tables are directly combined, and you can see first table first table like 11 records, second table 5 records, 11 into 5 total 55 records got printed. So there is a duplication. So you can't apply join directly. It's just like a cross join. This is a Cartesian product, I can say. A into B, number of rows into number of rows in first record and number of rows in second record will be multiplied. So we need to apply a condition. What is the condition? There will be some what is the common point in the both tables? In employees table and department table, the common point is department ID. Yes or no? Department ID, right? So where department ID is equals to department ID. But you can't take department ID, because if you take department ID is equal to department ID, the SQL engine will be in dilemma. So we need to create the alias. So here we need to take employees E. E is nothing but alias, departments D. So employees department ID, so E dot department ID, departments department ID D. like this. So now let's check. So now total, you can see total, the total 8 records where both the tables got matched. So I don't want to mention all the table, all the columns instead. Let's mention employee's first name and the department's department because we are combining right now based on the department ID. Based on the department ID in the child table, I'm going to get the department name from the parent table. Parent table. So let's write. So let's do one thing. First of all, employee's department ID with the department's department because department name is not there in the child table. We need to get it from parent table. Right. Perfect. And let's just print the first name. I think no need to use alias for the first name because first name is, let me just check whether we are going to get or not. No need because first name is only like first name is only available one time. Like it's not repeated, right? So Priya 30 data science like this. So these are the employees where I mean these are the employees where they have the departments and matching with the parent table, which is the departments, right? Now I can just write the same query like this also, where I just want to mention only employee's first name and department ID with like this. Okay. Now next one is left join. Left join returns all records from left table. We call it as left outer join also or left join from the left table and the records matched records from the right table and missing matches. There are some records are unmatched, right? Right. So matches generate null fields on the right side. So let's see that. That means initially the matched rows will be displayed. Whatever the unmatched rows are there, left side table values will be printed and right side will be null. Right side will be null. Now the next query is left join. Select, I think we can use the same query. Same query. Employee E. In between you apply left join department. It's not where, instead you have to use on. You can see uh, the left side table is like, let me remove this, only one column, let's dip so that we can, let's maintain equal. So this is related to employee left column. Let me execute again. This is a right table. So left table, first matched columns will be there. Remaining whatever the unmatched columns are there. So these are the unmatched columns, Neha, Jane, Surya. For this, left side values will be printed, right side values will be null. So like the same, let's go with right join, right outer join and right join. Returns all records from the right table and the match records, of course, match records from the left table. Missing matches generates null fields on the left side. That means first inner join, I mean first matched values will be printed. Now left side will be null and right side will be unmatched. So same right join, same right join. You can see null values in the first column row. First column, sorry. Write this. Right. Employee right join. Next, full outer join. Full outer join is nothing but join nothing but returns all records when there is a match in either left or right table records. Full outer join is nothing but left outer join plus right outer join along with the matched records. Let's see that. So same query, select e d dot department from employee e dot. Let's apply. I think full join is not there. It's not there. So let's just apply like this. First one I need to apply with left outer join, left join, left join, and I need to apply union. Union intersection. Union means all duplicates records will be deleted. Intersection means common elements will be displayed. Common records. That means matched rows. This is nothing but right outer join. Join and here you apply union. Right. Remove semicolon. Let's apply. Let's check the query again. Left outer departments. E dot department, D dot department. Yeah. Now you can see. So both left outer records and out. So you can see the output of left and right individually. Combination of both the outputs will be like full outer join. Matched records and then left null, right unmatched, right null, left unmatched. Because not all records got matched, right? Out of 11 records, only few records got matched. We already checked in the inner join. Next one is self join. A join operation that pairs a table to itself. So I cite something like per join, we need only at least one table is enough. Don't say it as multiple tables. By aliasing it under two different names. Like for example, self join. Within the table, let's take two columns. For example, select e dot employee alias as staff, m dot first name as supervisor from employee e. Supervisor means like manager, where let's apply within the table, right? Like equi-join only we have to apply because to match the records, equal operation. E inner join, employees, same, second table also same table. First table, employee. Here there is no second table within the table. So second, same table, employees, M, employees, M, E versus M on E dot manager ID. I told right, manager ID, employee ID, both columns having similar values. That's why we can apply self join is equals to M dot employee ID. Nothing. There are no values because I think uh, there are no values because let's execute first of all, select star from employees. All are null values. So let me just discuss about update query. Update query. Update query is nothing but like update table name, employees, update table name, set which column you want to change. Column 1, corresponding value. I want to update second column also. Comma we need to use to separate. And where condition. Where condition. If you don't keep where condition, without where condition, all records will be updated. Records will be updated. So let's do one thing. For update employees, where update employees manager ID is equals to 1. For example, for this employee, let's keep manager ID as 2, 2, where if I give semicolon, if I execute, all records will be updated. So sorry, it is set. If don't give, because it will update all records without where condition. So where I want to update for one record only, first record. Done. Let me check the records. So for the first record, okay. So for the fifth record, let's update. For the fifth record, let's keep employee 1 as manager. So two records where we updated. This one and this one. Now let's all execute this self join now. Amit Priya become Amit. Okay, right. Because Amit Priya and you can just mention their IDs also if you want. So because Amit Priya, Vikram Amit. Amit. For Amit, the supervisor is Priya, and for Vikram, the supervisor is Amit. But self join is also done. So, for example, as I said, like if you want to update all records without, for example, let's take a status. Update employee set status is equals to active. All records will be updated as active. It's a dangerous operation. Update employee set status is equals to. You're using a save without you're using save update mode, or you have to update all table without the column name. Update table name without where condition using a key column. Let's disable it. Let's all disable the where is the save mode we need to change. Otherwise the problem will be, let's check this preferences SQL editors to disable save mode, because without where condition it's not a save mode. Right? That's what is we have to change the save mode in the SQL editor. Where is the save mode? Yeah, save updates. Now let's run this. We need to close and open again. Are we going to get this or not? I didn't save actually. Thank God. So let's execute again. Yeah, all records got updated. Now let's just check the entire data now. Let's check the entire data. All records got updated without where condition. Everything. Now let's update like two records. Like I just want to update sixth record, for example. Update table name employees where no set first name. I just want to update as, instead of Ananya, let's take Anni, comma. Status I want to update as on leave, where employee ID is equals to 6. Only one that record will be updated. Right. So let us all check that record only instead of all records. How to check all that record only? Employees where that employee ID, where that employee is equal to what? 6. 6. Okay. So there is a cross join, right? I told at the beginning of this definition, cross join. Cross join is nothing but produces a Cartesian product. That means the number of rows in one table will be multiplied with the number of rows in second table. The problem will be duplicates. That's why people will go with join with equal condition. Only the matched rows only will be printed. That is very important. Cartesian. Without join, It pairs it pairs every single row. I repeat once again, every single row of the first table with every single row. That means the rows in first table will be multiplied with rows in second table. That's the disadvantage of what we call like cross Cartesian product, or called as cross join. For example, select E is alias from employee first name, D is alias from department name, from employees alias E, cross join. I repeat, cross join with the department's D. Okay. So now all rows will be multiplied. First record, 5 rows will be there. Second, first table 5 records are there. Second table 11 records are there. Okay. Now total 55. 5 into 11, 55. Yeah, right. That's the problem. So the last topic will be subqueries. Subqueries or nested operations. Subquery Subquery is also called as a nested query, is an inner statement located inside an outer query. So now as of now we completed only one query only. Now let us all start writing 2 to 3 queries also in the single query, in an outer query. The inner query, the inner query, the inner query executes first and passes its results to the outer query to filter or to compute data dynamically. First one is a independent scalar subquery. A subquery that operates independently independently of the outer query and returns exactly one row and one column. Okay, the subquery that operates independently of the outer query and exactly will give you one result only. Let's see that subqueries. So now the next topic will be subqueries execution. Hyphen subqueries. Select, let's take first name and the salary from table name employees, where salary is greater than. First I first I want to first I want to get the average of salary from employee table. That is my inner query. So that average salary will be checked with the outer query. So what will happen? First, this query will be executed. This will give you one value. So salary greater than that value, employees will be displayed. Okay, right. So first, let us all check the average of salary again. I mean, we already checked while we're discussing multi-row functions or aggregate function. 80 80,700 is the average salary. More than that, what are the employees we have? So we have nearly 4 rows where 80,700 salaries. This is so. What is the inner query here? Select average of salary from employees. What is the outer query here? First name. So first inner query will be executed. That result will be passed to outer query, and independent scalar means single value will be exactly one row and one column will be printed. Okay, exactly one row and one column. That one column is like we call it as a single scalar value. Let's go with multi-row subquery, very important. These are the complicated queries. It is very important for web application development. Not always only CRUD operations will be there. Multiple advanced queries also will be written. A subquery, A subquery that executes independently but returns multiple rows containing a single column. We used with in operator, any operator, and all operator. Let's check this. Select a star from employees where department ID in of now multiple values. Now the inner query is going to give multiple values. Select a department ID from departments where location in of location in of location in of. Let's take some set of values. Inner query is going to check the inner going to is going to give the department IDs of some set of departments. Let's take a location of San Francisco, which we given in the departments initially when we insert the data. Next one is Seattle, right? So inner query, there's a one mistake, I think regarding semicolon. Let's execute this. See, the inner query is going to give you a list of department IDs of San Francisco and Seattle. So let us all first execute the inner query first. We are going to get the department IDs of San Francisco and Seattle. So sorry if I'm misspelling the location. 30, 30. So first iteration 30 will be there. Next iteration, like let us all, if I give like this, San Francisco. Let me check the spelling. I think it should be same as it is. One second. Let's check the select star from departments. Very important. Okay, San Francisco is not there. That's the problem here. That's why 30 is for Seattle, right? Yeah. Let's give New York. New York. Yeah. Now let's execute this. Let's execute the inner query first. Let us all check the department IDs of New York and Seattle. 1030. Okay. Now 1030 based on 1030 department IDs employees. So 1030 department IDs employees, those who are working in 1030 department IDs, that employees list will be displayed. Okay, total 4 rows. Perfect. The next one is correlated subquery. Correlated subquery. A subquery, a subquery that depends on values from the current row being processed by outer row. We successfully completed 3 hours from now. Like, let's just continue this session till 5:30. Next half an hour, this session will be over. Thank you for your continued support. It executes repeatedly, once for each row. The previous query is something like first after the execution of inner query only, the outer query will be executed. But this is something like for every iteration, like one value will be given for every iteration by the inner query, right? That value will be compared with the outer query and the result will be given like that. Individual row evaluated by the outer statement or query. Let's see the example, a simple query, but it is a complex query. Select E1 alias 1 for the employee, E1 salary, E1 dot department ID. Salary is a small letter, right? Here you keep semicolon from two one alias, E1 is alias of employee, where E1 dot salary greater than select AVG of E2 dot salary from employees. E2 inner query I'm writing E2 where E2 dot department ID, E1 dot E1 dot department ID. Inner query is going to give you average salaries in which where department IDs of both the tables must be matched. It's like inner join. Let's execute, right? So these are the so individually first. I mean department IDs. E2 E1 is the alias of outer query. E1 is the alias of inner query. First name, salary, department. I can't execute inner query separately because every time, I mean, the query is something like this. Department ID wise, average of salaries will be calculated. Then based on then then department wise, first name, average of salary. I mean, not salary, and the department ID will be displayed. Will be displayed. Let's just talk about the very important placement approach queries. It's very important. Like queries with, for example, I want to calculate nth salary, nth highest salary. Like for example, I want to finding first one finding third maximum salary. Okay, let's see how to calculate third maximum salary. Third maximum salary. Select first of all for the first maximum salary, it is something like select max of from employees is a table name. This is the first maximum salary. Right? Third maximum salary is something like let's take let's go with second maximum salary. First of all, let's do one thing. Let us all print all the salaries in descending order. Salary from employees, order by DSC salary. Error, error. Column name and then DSC. Right. So 14,000 is the first salary. Okay, perfect. Let's print third maximum salary. Let's print second maximum salary. First, third, or second, like that. Anything is okay based on it. Let's print third max salary uh, from employees table as third maximum salary. That is alias name, new name, where your salary should be less than salary should be less than select maximum salary from employees, where salary less than select max of salary from employee. Let's close this. Third maximum salary is 95,000. 95,000. Right. Let me bring second maximum salary also. Then I'll explain this query. Second maximum salary. Second. Second maximum salary is how much? Let's execute this 12,000. Okay. Sorry, 1,20,000. Perfect. You know, first maximum salary will be taken and where salary less than. So while calculating the next salary, I mean, if there are five values are there, for example, max of salary, if there are five salaries, where when first maximum salary will be calculated, when you want to calculate second maximum salary, that max salary will be omitted. Among the remaining values, the max salary will be taken. For third salary, first two maximum salary will be omitted. So the third max salary will be calculated from the remaining values. Like that, you are keeping condition that less than, again inner query, less than inner query like that. So if you give multiple inner queries like that, every inner query will omit that maximum value, that is first maximum value, second maximum value, third, and so on. Right. So I executed first maximum. First is very easy. Select max of cell. Second is keeping this inner query like this and omitting that first max salary. So whenever you check this, whenever you want to get the second max salary, you don't need first max salary. So we need to omit that or uh, restrict that. Now there is other approach also for this. So we can directly use like we can have a generic formula approach where if you want to print a specific nth salary, so I can use offset method which we discussed. Offset is something but starting position select. Let's take a distinct salary first of all from employees. What will happen for the distinct salary? I think null is there, right? So somewhere around we got salary employees. Okay. So do we have null? Yeah, null. So we need to omit this null. For example, how to omit this null where salary is not null. All null values will be grouped into one null value. I think we already discussed, right? This operator. We can go perfect total these values. And now let us all apply order by. We need to apply descending order by. So now, right. Now, if I just want to get one, limit one means first max salary will be printed. Okay. For example, if I want, this is for third highest salary. Third highest salary means limit one. Take offset two. Offset two means third record, right? Because index starts from zero, right? Same one. If I go with second highest salary, limit one, one, 1,20,000. Perfect. So next one is views. Views are nothing but a virtual table based on the result set of an SQL statement because you don't want to view all the columns in the table. You want to create a separate table from the main table that is called as view. It doesn't store physical data itself, but but acts as a saved window over live databases database tables. To simplify, because every time we need to look into multiple columns, right? So it will simplify the queries also, logic, and it is going to isolate. I want to save some sensitive columns in a separate table. So in that sense, I can use in that context I can use what we call views. So views is nothing but a virtual table based on the SQL statement. So let's execute views. Here views. So how I'm going to create views in the sense based on the select statement only. So I want to create a view with the name as a uh, text staff view as select employee ID. I want to keep like 2 to 3 columns, first name, last name, and a status. From which table? Employee, where where department ID 20. So first of all, let us all see what is the department ID 20 employee ID, employee name. Sorry, department name. Select star from departments. 20 is engineering department. If you want to get it from employee table, then select, no, let's execute this. Let's see the error here. Status, okay. Right, 0 rows affected. Now let us all select the star from, let's see the new table, a new view actually, view, text tab view. So 20 department records will be displayed here. 20. All 20 department employees are there as a separate view. Right. That is the purpose of view. Like that you can create. For example, I want to create a new view, create a view. My view name is salary greater than 1 lakh. Example. For example, let me take a simple one, salary view. Okay. As select first name, of course, last name, and the salary, uh, where salary greater than 1, 2, 3, 4. I want to create a view like this with more than 1 lakh. First name is not in there. Oh, I need to use from employees. Now let us all see this new table. This is a view. So only more than 1 lakh salaries. These are the two records displayed. So the next one is indexes. Indexes, a special lookup structure that an RDBMS uses to speed. If you want to make your retrieval speed up, then we use indexes. If I, if I just want to my search faster based on first name, so we can create index on first name. What will happen if there is no index? Without index, the problem will be the database must scan entire table, row by row, entire table row by row. That is a full table scan. Now I'm going to create index based on some one column or more than one column. So let's see the indexes. Indexes. Create index. The index name is, for example, index underscore. I want to create based on employee last name. On which table? Employee table. On which column? Last name column. So like this, you can create indexes. Now some built-in functions are there. There are many built-in functions. Let me first focus on few. Select concat is there. I want to apply concat on first name with some space like this, and then last name as full name. Full name means first name space last name. And I want to uppercase the status. And I want to print the length also of first name from employees. Right. Function contact directories. What is contact? Sorry, contact. Sorry, my bad. Perfect. So you can see full name and the length also clearly. Oh, and next one is we can round off the salaries also. There are many functions we can use. Round off. My salary, I want to round off, numeric round off with -3 from employees. Right. What is the difference between normal salary and round off salary? Okay. If I just want to reduce with one, I think there are no 0.45, 0.55 like this, right? Yeah. Zero. Okay. So we completed all type of queries, create, update, everything and all. So let me just talk about the TCL commands also, like how to master in TCL commands, very important. Okay. So what I'll do is like, let me create a new file, new query file. So what I'll do is like, let me auto commit, let me disable auto commit with 0. Okay. So TCL commands. And now before that, let me create a table, like create table product. Let's do one thing. I think, yeah, I'm okay with this. Set auto commit. Let me run it. I mean, I want to create new tables. I'm okay with this. So set to auto commit 0. Select star from departments now. Right. So like this, we have values, 5 values totally. If I just want to give count of star, total 5 values. Okay. Now the point here is like, let me execute this query again. Auto commit is now off. So every time we need to commit. Now let me update my department table with the set location as Hyderabad, where department ID is equals to 20. Done. Let's check here whether the query got executed or not without error. Yeah, one record got changed. Now point is, now let us all check this query. Select star from products. Sorry, department. For 20 department ID, we changed Hyderabad. Okay. If I close this and if I open my SQL Workbench, let's close and open my SQL Workbench. Let's go to TCL. Not there because we didn't commit the data. That's the problem here. So commit is very important. So how to restore, for example, rollback, semicolon, run it. Now, if I try to execute this again, check, let us all check whether we are going to be able to roll back. If I just open this, if I just open this again, TCL, not there. So rollback can be possible only when you just want to commit the data. So what is the thing we need to do? Just execute this query. After the execution of this query, make sure you commit the data. Okay, now let us all see the departments. It is there. Now let's close and let's open MySQL Workbench. So commit is nothing but, see in MySQL it is auto commit. That's why you don't need to commit it separately. Let us all check the departments. Hyderabad should be there. Perfect. So every time we miss to execute commit, right? That's why in SQL it is auto commit, right? Like this, we can create save points also. So for example, save point, let me write here. Like this, we can create a save point also. Save point name. And if you want, you can roll back to whatever the save point you want. For example, I want to roll back to a specific save point. Roll back to that save point, and we need to mention the save point name here. So we can restore to any save point you can go there. For example, I updated Hyderabad, right? I created one save point. After some records updation and all, I want to go to again the previous one. So just roll back to that save point. So revise normalization and transaction management like asset properties. Normalization is nothing but to remove the anomalies like update anomaly, insert anomaly, delete anomaly, and all. So this is regarding my master class. I covered, I think, all kind of commands like subqueries, everything, all functions. I just want to highlight important point like delete, uh, yeah, insert, update, delete, select, done, and TCL grant revoke is used to assign the permissions like to the multiple if multiple users are there, I can just create I can give the permissions like accordingly. Regarding delete, for example, if I want to delete all the records, delete from table name department, I want to delete only employee department ID 50, for example. So it is not possible. It is possible because it's 50 records are not there. Like, I mean, in a sense, 50 department ID is not there in the employee. Let's check in the employees. 50 department ID is there or not? It's not there. That's why it is not showing any. If I give you, for example, 20, 20 will not be deleted constant ever because there is a 20 department records are there in child table. So first we need to delete that. Delete from employees. There is a relationship, right? So the child record should be deleted first before going to delete parent record. That's why foreign key is very important, where department ID is equals to 20. So let's remove 20 department records. I don't know like how many will be deleted. We can just display the count also. if you want. You can display the count, how many departments with 20, count of department ID from employees where employees where department ID is equal to 20. Three are there. So total three records will be deleted. Perfect. Now let's delete the parent records. Perfect. Now let's see the departments. Okay, 20 is deleted. 50 deleted. Okay, already deleted 50. Okay. So we can delete based on and some name also we can delete accordingly. If you truncate the table, for example, like truncate table, employees, employees, done. Now let's see the table. So data will not be there, but table structure is there, right? That is important. I already discussed DSC space employees. For example, drop table employees. Already data is deleted. Now the schema also will be deleted. Now if you see show tables, not only only department is there. These two are views. Okay. Now let's drop departments also. Right. Now show tables. There's a very important point. If you drop tables, for example, note point. If you drop a table, everything will be deleted, including constraints also, which you created manually after table creation, but not views linked to it. Views will not be deleted. Okay, right. So thank you so much, and I hope this session will help you like in performing different types of queries. So you can just revise the query whenever you need. I mean, all the queries, all different types covered, and you just do any kind of use case also, like take a e-commerce database like products, orders like that, and then perform multiple queries with this all these operators so that you'll get a better clarity on everything. Thank you. Uh, thank you so much, and for more updates, please, like I request you to follow my Instagram channel and my YouTube channel, Web Sadhana Samyoga. So this series will be continued like this. We'll complete full stack and the competitive coding parallelly, and then next contemporary technologies like DevOps, Gen AI will be continued. But this is for beginners. So those who are studying first year BTech, second year and all, first they need to know the competitive coding as well as web development skills. Without web development skills, please don't getting into any kind of uh, without competitive coding and web development skills, please don't getting into any kind of like new technology. First, we need to know the basic skills. So people will like suggest you to go with AI technologies directly. Don't know. First, you need to know the basics part, how to develop application. Then you can use AI tools and all to develop a code, right? Thank you so much, and all the best for your future. Thank you.